Hello students. So yesterday we have reached up to this point. This is series continuing number Pakke. Number Pakke means marks assured. So marks are assured when you revise or when you study one chapter thoroughly or one numerical. IITs generally they don't give theory in the exam. Even if you know the theory, but you're missing some trick in the numerical. So all theory is waste. So we are concentrating on the tricks in the numerical. So in the number Pakke series, we reached up to this point the general derivation when two particles are thrown upward simultaneously at the same time, and we are supposed to know the when, where, and with what velocities they collide in the air, in the flight. So I have written some steps to remember, and these are first of all, because you need to do the calculation very fast in the exam. It's immaterial how you do, how you solve. You have to reach the answer correctly. So for ease of calculations, faster, remember, you convert these formulae V is equal to U plus AT, as we discussed yesterday, that G is always negative, and that is minus 10 meter per second square instead of 9.81 we take for the ease in calculations and just to check the understanding. So we have put the G is equal to minus 10. So these equations reduce U plus AT instead of writing U plus GT and then converting in the exam and taking a long way. So straight way, remember these equation. V is equal to U minus 10t. S is equal to ut minus 5t square. V square is equal to U square minus 20s. So only these three equations we will be using to solve any numerical in motion in vertical direction with collisions or without collisions. So these are the three steps yesterday. First of all, quickly find the time of their meeting when one is projected from a height and another is projected from the ground or from any difference in their height. So the time is calculated h divided by u1 minus u2. u1 minus u2, that is velocity difference. Velocity difference means relative velocity, and this is height difference h. That may not be necessarily ground in the top of any hill. That may be any height difference or initial relative distance. This is relative velocity or initial relative velocity. Actually, the relative velocity initially and velocity at any time will remain constant relative velocity, and that will be u1 minus u2. One simple corollary of this equation h divided by u1 minus u2. Suppose I ask you that when u1 is equal to u2, so in this term becomes 0 and t becomes infinity. So that means when u1 and u2 they are equal, those particles will never meet. They will meet after infinite time. Secondly, suppose u1 is less than u2, so then the time will be negative. That is again, that means they will never meet. This u1 is less than, this will take some flight up to here, another one will go up, and before it comes back to meet this, it will fall on the ground. So this cannot be negative, this cannot be 0. It is simple inference from this formulae. Once you calculate this time, then v1 and v2 from this simple equation u minus 10t, put the value of t, u you know, t you know, so you get the velocity v1 v2, and then s1 s2 ut minus 5t square. So now let us come to our next point. We step towards twist 1. Okay, so students, there is twist 1, that one possibility in this numerical, that there is a time difference when we throw these two objects from the height or from the ground, there's a difference in elevation, there's difference in time also. Then when, where, and with what velocity they will meet. So that could be the question. So let us solve this. This is simple way to bring it back to the original question. First or second object is thrown after a time interval t1. So object 1 suppose is thrown upward, and after time t1 object 2 is thrown upwards. Then distance s1 t1, that means some distance it travels from here to here. That distance will be this one, u1 t1 minus 5 t1 square, by this equation. So this distance it travels, and after that when it is thrown, so remaining h remains is this. And this velocity also, suppose at time 0 it was u1 0, so that velocity will be here u1. So we will modify the height h and the initial velocity of the first particle that has been already thrown. Similarly, and we will repeat the same procedure. So students, when reverse happens, in case reverse happens, then object 1 is thrown after object 2. Like 2 object is thrown upward first, after that the first is thrown with the time after the time interval t1, then modified h height is original h0 plus this s2 t1. That means the time traveled by this in time t1. This distance traveled by this in time t1. So h0 plus this is the modified height as in earlier case, and this is the modified velocity, initial velocity of another particle. And this numerical after this modification remains same as the previous one as we were solving the derivation, or as Kanishk solved earlier. Please you avoid this equation. S is equal to ut minus 5t square. Please avoid this equation, though there is nothing wrong using this equation, but it gives 2 times. One of them is correct because it's a quadratic equation, and solving it takes longer time. So with what velocity they strike the ground, we will find out first. So this particle fired from the ground returns to the ground. The displacement of the particle or the is 0. So we know the displacement of the particle is 0. Initial velocity we know. So we have to find the final velocity. So we use this equation v square, that is final velocity, rather v1 square for this particle, is equal to u1 square minus 20 s. Mind it, s is not, it will go upward and come down. So distance will be twice going up and down. But the displacement, we are dealing with the vectors now. I reminded you of the sign convention in my previous lecture because of this. Because it's easy to for the calculations if we use in the vector form velocity and displacement. So here this displacement is s is equal to 0. It goes up, comes down at the same point. So when it is 0, so v1 square is equal to u1 square minus 0. So v1 square is equal to u1 square, that gives us v1 is equal to u1. Am I correct? there's some mischief here, or there's some point we are missing here. Is it correct? V1 square is equal to U1 square? Yes, it's not correct. V1 is equal to plus minus U1 because squares are equal. And when this particle goes up, this is U1. When it returns, this is, we will take it minus U1. So velocity of the particle at the ground when it returns the ground for the first is minus U1, not U1. Once we know this final velocity V1, then we use this equation. We know V1 is equal to U1 minus 10t. V is equal to U minus 10t. Earlier three equations I wrote in the beginning when I started this lecture. And this gives us V1 is minus U1 is equal to minus plus U1 minus 10t. So that gives us tan t is equal to 2u1. That gives us t is equal to u1 by 5. You know this in earlier your experiences with such type of numericals. They were simple. It used to come 2u by g, I think, something like this. Something like this. So this is u1 by 5. So for first, similarly for second, v2 square is equal to u2 square minus 20. What is displacement for this particle when it reaches the ground? What is displacement? H? No, some students are saying H. No. Minus H. Sign convention, downwards. It is at the top. So displacement is minus H. So S is minus H. So what it becomes? u2 square plus 20h. And once we know this V2, so again time t we can calculate. So students, now we come to the collisions. So for collision, what we require? Only the initial velocities and mass before the collision and initial velocities and mass after the collision. So in inelastic collision, when where the kinetic energy is not conserved, only momentum is conserved. Momentum is conserved in both the cases, elastic and inelastic, both. But suppose the collision is perfectly elastic, that means no energy is lost, no kinetic energy is lost. So we call it elastic collision. In inelastic collision, we are given u1, u2, and because when one is embedded in another, so this v1 and it becomes equal to v2, both move with the same common velocity, combined velocity. So only one unknown, we find one unknown by this equation, as we found in the numerical that we started with, first of all, what Kanish solved earlier. But suppose the collision is half elastic or inelastic, or it's a mixture of both, or perfectly elastic. In case of perfectly elastic, These are two equations. One is this, second is this. So two unknowns, V1 and V2, and two equations. So we find V1 and V2 for both after the collision. And once we, the further question can be asked, the energy lost in the collision. So energy lost in the collision is kinetic energy after collision, okay, and kinetic energy before collision. Difference of these two is loss in energy. You know, like commonly when two cars collide, that may be like elastic or inelastic or midway. So some energy is lost in their collision, and that energy is lost in the form of sound, in the form of deformation, in the form of heat. So that's all for today. You give me some problem, you tell me what twist can be there in this numerical. I hope after knowing all these derivations, you can solve any numerical on this topic. Motion in vertical straight line with collision. So that's all. We expect the students that give us the problem subscribe to our channel. We are running a coaching institute in Coaching Hub Jaipur, and it's very good infrastructure, world class infrastructure with world class facilities. You can join us online, you can join us offline. Joining online is free for all on YouTube, on Telegram channel. If you request us, you give us problem, next time we give you the solution. So please send your comments on the Telegram channel. Our Telegram channel is same written here, Tewatia IIT NEET. It's a Telegram group. Please send your comments here, and next time we may telecast our channel online on Telegram and on YouTube and on Google Meet. Thank you.